Hello and welcome to my screencast. This video is gonna be the first of a few videos that I'm going to record over working with legacy code. Basically, I would like to share some tips, tricks, and techniques that everybody can use in order to improve their, to actually deal with their legacy code. Those things are based mostly on two books that I've read, and I strongly recommend everybody to read. First one is Working Effectively with Legacy Code, and also the Refactoring book. My name is Jovce, and without further ado, let's start. So the motivation for the whole thing is a friend of mine asking a question. He posted a code and he asked for resources where he can learn how to start improving the legacy code that he's working with. So I took that code and I decided to record these videos. First, I'm gonna create a package and a class where I'm gonna post that code so we can start working with it. So this project is, I'm doing this in my katas repository. You can find it on my GitHub if you really want to. So here is the code that he posted. I took that code and so we're gonna work over this one to make it better, to improve it. The first thing that I would like to point out here is the frequent commits. Frequent commits are a really good way of working, but especially when you're working on a legacy code, making a mistake is super easy because it's really unknown what we are doing, what the code does, all of those things. Reverting back is gonna be hell. If we have little commits and really frequent, reverting back to a state where we can continue from, if we make a mistake, would be way easier. So I'm gonna start with a commit now. I'm gonna name it imported legacy code which does not compile. Right. So to begin with, let's make this code compile first, and then we can start on improving it. Now, most probably this was a real project, there were real types, and if there were real types, there are techniques that we can use in order to still be able to focus on only this part of the code and improve it. We're gonna discuss them over this series of videos. However, right now I'm just gonna generate them, and because I just want to describe the techniques. That's a really important part of these videos. So to begin with, I'm gonna just extract the types here internally, but I'm gonna make them static so it will be easier. I don't want them to have any reference to this legacy class, and it will be easier for me to move them later. The goal is to move them away from this one. So this one is also, this one, yeah, it's part of the standard Java SDK. UUID also is part of the standard SDK. These are methods. So first I'm gonna try to extract the types, and then I'm gonna work on extracting the methods and the constants. Here is another type. Also I'll make, oh, this one static and this one also static. Get back to where I was. Yes. Yeah, and this one also, it appears to be instance variable or a field, so I'm gonna make a field. I'll take the same name, put it here, use a, yes, and create inner class. Also make it static. Oops. Good. Okay, now let's take a look at the constants. Okay, this seems to be an int because it's an index. It makes sense to me to be int. Then, okay, let's better maybe. This is a collection card type, and this name most probably is going to be string. I have set my studio to whenever I generate a method to throw an exception. So if I call that method, I'll know what's being invoked, so I can start on I can work on implementing the methods that are not being implemented. This appears to be constant. I believe it's list of string because it checks if it contains a name that is a string, so it makes sense. I'll make it empty for now. Yeah, I would like to just separate the static from the instance with an empty line. That's just preference. Okay, initial count also seems like an int. And then, yeah, this one also seems to be an int. Yeah, I just use 0 for all. Then, okay, let's start with the methods. This one seems to be a local method. Here we have UUID. Is empty also a method here in the legacy class. This is method. Okay, fine. Yeah, one little tip: whenever you are generating code like this, if you have resolved all the types that are being passed as an argument, then whenever you have to generate that function, all the types are already known. So whenever you have to do that, try to first, do in that order. First resolve the arguments and then make the actual function. It's gonna be a little bit easier for you. This is int. And then, yeah, like here, for example, we have delete, but we don't know what's this type. Okay, so we have action default card. Okay, we don't know, but most probably it's gonna be the same card type. I just guess so. And then, cool. So now I have the code compiling. I'm gonna make a commit here. The code is now compiling. Yeah, the code is now compiling. Good enough. Okay, so before, right now what we can start doing is extract these types in separate classes. So we are gonna reduce a little bit the clutter here. I'm gonna use automatic refactoring from the studio. That's always safer than actually doing manual refactoring. So whenever available, just use it. Most probably it's safe. Like 99% of the times it is safe to use the automated refactoring. But again, when dealing with legacy code, be extra careful because you never know. This one also. So I just move. Yeah, I'm moving them in the same package. It doesn't really matter right now. Move. Okay, where we are. Yeah, and this I think is the last. Good. Yeah, again, make a commit, moved inner classes outside the initial class. Good. Yeah, so this method is feature enabled, is taking user context, and it is being called here. Yes, so if not feature enabled. Okay, I think, yeah, it takes user context, and most probably it's gonna be doing some operation on the user context. It makes sense to me to move this method in the user context, because this is an implementation detail of the user context, and it appears that this functionality that we are having in the legacy was a feature envy. The legacy shouldn't really care and know what is the internal of this user context, and shouldn't care. It just uses its interface, which is the isFeature enabled function. Okay, good. I think we're gonna just make another commit. Eliminated feature envy. Yes, I think that's good. Okay, next. Is empty. Yeah, so I think this one is taking a list of card types. I can just assume that this one should return if the configured action cards in order is empty. And what I can do right now is I can inline this method, and if I get back here, yes, it is just checking if it's empty. So again, I'm not sure if the real code was doing this or how it was checking for emptiness, but it doesn't really matter for this exercise. So that's why I just put this assumption here. Okay, so I think we have another use standard SDK standard API to eliminate feature envy. Yes. So I'm just gonna close that panel. Yeah, I think now we're at a better position. Okay, the next tip is I see this variable defined here, but it's not used in the block below it. So it's pretty safe if I just move it down. And now if I highlight it, I see all the highlighted places where it is being used. I cannot move it any closer. So the tip is move all the definitions as close as possible to the place where they're used. That's gonna be really helpful. So I cannot move it any closer, but now it actually helped me a lot, because now I think I can move this one into another method. So this method name is validate and update default card. So basically this is the actual update functionality. I can name it update default card, right? And now I have to check this in. Oops. Let's name it separated validation and action. Okay, now what I can do, I can merge these two if blocks into a one. Oops, that was wrong. Yes. And okay, I can also invert if condition. Okay, first I'm gonna check this in to be extra safe. I will say merged if conditions, and oops, it's good that it failed actually, so I made this type as well. I normally want to start with capital case. Git commit message merged if conditions. Yes. And now what I can do, I can invert the if condition. Also, check this in, inverted if condition. And now what I can do, I can remove this return, I can remove the all else block. And that's actually way better than what we used to have. And now I'm gonna do another commit. Remove unnecessary else block. Exactly. So what we've done so far, we were using only automated refactorings from the studio itself, which are very safe. We should not change the code. I mean, anything else that we will have to do, it would be better if we have supported with tests. So the actual functionality, the actual flow of this method we should first write tests, put this whole functionality under test harness, make sure and have confidence that we are gonna have preserved all the functionality, all the flow, and only then alter the code. So before we write the tests, we cannot change this code any further, or at least I don't see where we can. Well, maybe we could, but it would be better if we just now apply tests, cover all the functionality, only then approach changing the code. And we're gonna start tackling that in the next video. So I think for now, for this video, this is enough. Hope you enjoyed, and thanks for watching. See you in the next video.